Hi, today we're visiting a forested floodplain wetland adjacent to the Red Cedar River near Michigan State University in East Lansing, Michigan. So first of all, let's cover what a floodplain is. A floodplain is basically the land area adjacent to a river where when water overflows the banks of the river, it will overflow into that adjacent land area. The extent to which it overflows is called the floodplain area. This usually happens after a big flood event. The three criteria a wetland must have to be classified as a wetland: it has to have water, hydrology, enough to support a dominance of wetland vegetation. That could be as little as 2 weeks per year. So again, the second criteria is a dominance of wetland vegetation, and the third criteria is hydric soils.
So here I've dug a soil pit approximately 15-16 inches deep. Sometimes you got to go deeper, but in this case we can see what we need to see at that depth. When we're looking at soils, the main coloring agents of the soil are the amount of carbon, and carbon's going to have a black appearance. Think of like muck that accumulates in saturated soil conditions on the edge of lakes. That black soil material that is dominated by carbon. The other coloring agent that we have is iron. In an oxidized state, iron is red or orange. And think about up in the uplands, high dry areas, the soils typically have an orange hue to them. That's because the iron in that soil is oxidized. As you get into the wetlands, what you see is that iron becoming anaerobic, and when it does that, it becomes colorless. It also becomes mobile and is able to move around easily. So we have water comes in here in the spring, floods the area, everything becomes anaerobic as the oxygen is used up, and then the water goes away, the oxygen can come back in. And that's kind of what we're seeing here. We're seeing some dark soils at the top, a lot of organic or carbon in this top layer that is causing a really dark color. Indicates that potentially we've got some wetland hydric soils here. But what we really need to see is underneath here, where we've got this gray color, which is the base color of the soils, with some red spots. These spots are really a good indicator of fluctuating water level. So they do indicate that you have standing water or soil saturation for a significant period of the growing season. That might be 2 weeks or longer, but the water goes away. So it actually dries up at some point during the growing season, allowing the oxygen to come back in and the iron to get oxidized.
These forested floodplain wetland areas can be very productive because when that water overflows the riverbanks, it also carries with it sediment, and attached to that sediment is often nutrients. So you can see the area that I'm standing right now has really lush vegetation, and that's pretty common in forested floodplain wetland areas. It's getting enough water to support a dominance of wetland vegetation. It's getting a lot of nutrients from the overflow from the river. And it's also a great place to store that excess flood water during rain events. If the floodplains were cut off from the river, that water would be accelerated in the river, which would increase erosion. It would keep going downstream until it finally found a place to overflow the banks. Eventually, it might escape the banks and cause further flooding downstream. These floodplain areas are also really important areas for migratory songbirds. They're stopover spots for migrating birds. They do a lot of nutrient recycling, of course, stormwater storage, fish, wildlife habitat. They're great habitats for plants and animals and amphibians. And so they have a lot of really important functions and values. Hi, we're standing in another area of the floodplain of the Red Cedar River. Now, I want you to take a look in this area. Unlike the other area we looked at that had lots of rich vegetation dominating the understory, you can see there's like nothing growing here. And it's just like mud and matted down, dark stained leaves. And if you look closely here, you can see there's water marks on the trees. This is evidence that there was once standing water here early in the year, most likely in the spring. And because of that, this area could also be called a vernal pool. Vernal pools can be really important breeding areas for amphibians and salamanders, because there's no fish here, because there isn't water all year round, and it affords them some protection from predation. So you can also see, as far as functions and values, this area is storing a lot of water in the spring when the river does tend to overflow its banks. And so it allows the water to come in and then gradually be metered back out into the river or soaked down into the ground and help store floodwaters and prevent more flooding downstream. Let's talk a little bit about wetland terminology. Wetland delineation is basically delineating the boundaries of a wetland, right? Wetland mitigation occurs when you have destroyed wetland as part of some kind of development project and you're required by permit to restore or recreate wetlands to make up for what was destroyed. Wetland restoration is basically restoring an area that historically used to be wetland, returning it to wetland now. So a lot of times that can be in areas that are farm fields. So a lot of wetlands were historically drained for farming. A lot of times they put underground tile systems or they dug ditches to drain them. If you break those tiles or you fill up the ditches, you can restore the water to that area. The seed banks still in the soils in those areas can turn back to wetland. Wetland monitoring is another term you may hear. That is basically after, let's say you've created a wetland mitigation site, you have a permit, and often that permit will require you to monitor it anywhere from maybe 5 to 10 years to ensure that you've successfully recreated that wetland. Wetland restoration, I want to point out, can be done as either part of a wetland mitigation project, or it can be done separately, just maybe by a property owner who wants to restore wetlands as not part of any kind of permit process. So the U.S. Fish and Wildlife Service has programs that will go out and work with property owners to do voluntary wetland restoration. There are some groups like Ducks Unlimited that do similar type projects. And so I just want to make sure you understand that wetland restoration is a tool that can be used as part of a permitted wetland mitigation project, or it can be done separately on a voluntary basis.
I'm standing here in a vernal pool, a low area adjacent to the Red Cedar River. I want to walk over here slightly and you'll see the vegetation actually changes from no vegetation to, I guess, sparse vegetation in the more upland species, basswoods, sugar maples up on this ridge. So a little drier ridge. And so I want to talk a little bit about what forms this. The river is just beyond that ridge. So the river is flowing, and during flood events, when the river comes up, it's got maximum amount of energy. It's carrying a lot of sediment from runoff, and over time, as the river comes up, it deposited, and overtops the bank, it deposited sediment along the edge and throughout the floodplain. But the heaviest, largest sediments are deposited along this ridge, which has now turned into upland. Over many, many years, many flood events, the Red Cedar has flooded up here, deposited sand and gravel in those areas, has flooded these backwater swamps that we're standing in as well. But typically these are getting sediments, the lighter sediments that can float long enough. So back here is your finer sediments like your clays, and a lot of those clays are sediment laden, so you get a lot of sediments being deposited in these backwater swamp areas. So a neat little feature of river floodplains. Keep an eye out for it throughout the Midwest along these larger rivers. You will see these ridges, upland ridges being developed. Even with large swamps in the floodplain, you'll still have that feature. Okay, we're here on Michigan State University's campus in Baker Woodlot. Baker Woodlot is an old growth beech maple forest, and within it we have these pockets of wetland. So the forest for mostly is upland, non-wetland, and then we have these pockets of isolated water areas, or what we call vernal pools, that are seasonally wet and dry out, usually throughout the summer and into the fall. What we get here is a tremendous diversity of plants and animals that utilize these areas in conjunction with the upland forest. So critical to have these two components of the upland forest and the wetland. So an isolated system in this woodlot fills up, and when that fills up, it becomes critically important for amphibians. So you get a lot of salamander reproduction in here, frog reproduction. With one of the most critical things for them to be successful is that these ponds dry out and they are fishless. So fishless vernal pools, critical for amphibians and reptiles. So really nice example of that here. So here, again, we're here in this beech maple upland forest with a little vernal pool, wetland within the forest. So as the regulations work, the upland areas are not protected. So somebody could come in and develop a subdivision around these vernal pools. The vernal pool, the value of the vernal pool is that it has this intact upland around it. And so for animals, they have to have intact upland and these really high quality wetlands to support their life cycle. So developing all the upland could have a significant impact on what can utilize these wetland areas, as well as the plant diversity. So be aware that the protection of these areas is limited when you only can protect just the wetland areas.